Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Okay, so thanks for joining. We are one person short, Smith. Okay, so we were discussing about what is the difference between Chef, Puppet, Salt, the configuration stack, and then the Docker, and then the Kubernetes or this form. So the answers were like this configuration stack is mostly concerned about the configuration management, and then Docker talks about application virtualization, and then Kubernetes is an orchestrator, though we did not discuss about that. So let me try to put it in some layman words, and that's how I see it as a configuration management. So whenever you will have stacks of servers which are running your n number of applications, and those stacks of servers will have different operating systems, different dependencies as per the need of the software which you are running on it, different configurations for security, authentication, authorization, all those caveats will be running, right? So what happens in the real world is you might be able to do it with the scripts or manually in some server stacks, like wherever the numbers are less. But the moment you go beyond a certain threshold, so either you need to increase the number of people or you need to find some automated process. The moment you increase the number of people, you will increase the manual touch points, and the moment you increase the manual touch point, you will increase problems in the system. So that's why people move to automated configuration management. Okay, so coming back to the automated configuration management, thinking about when we are talking about Docker, so is like we'll not be touching anything on the configuration management. I'm talking about from the interview perspective, like how exactly it works, the questions which they'll be asking. So currently we are running all our infrastructure or all our practicals on one of the AWS machines, right? And that machine operating system we chose like it will be Ubuntu. And then we have the control of the security group. We know which code we need to expose and who is having the privileges and all those things. Consider all these things being handled by some other second system. Okay, so this level of configuration, when it is fed to the machine on which your Docker workloads are running, let's just for the sake of simplicity, you can have it as native Docker workloads, whatever we are practicing today to understand intricacies of Docker. So if that configuration is fed from some second or third system, so that's where we see the magic of configuration management. If I have to extrapolate it a bit, So think about your master node and your slave nodes or your build server. Okay. So what will happen is you will have different build servers, let's say n number of it, and then you will have, let's say you have a build server 1, you have a build server 2, you have a build server 3, right? And the moment, let's say you don't have a curl installed on all these servers and you want to, or you want to upgrade some security patch, or you want to upgrade some dependency, let's say you have JDK version, some version running here as let's 6, and here you have 7, and here you have 9. So if you have these kind of setups, right, and these are your build servers, so you can run some stack of applications which need 6, and let's say those applications got upgraded. So what happened is you can manually go and upgrade your 6 to 9 or 6 to 7, or you can have a configuration management setting somewhere else doing it. What it will give you one holistic way to handle or to visualize your application state. So this is pretty much about the theoretical aspects of having a configuration. As part of Docker, we are handling application virtualization. So you will have dependencies here, you will have your OS here. So you don't want your native code to be exposed to the operating system. Rather, you will have your dependencies as well coupled, combined as part of an image, and then you will instantiate a container out of it, or rather a boxed process, okay, which will run inside its confined boundaries and confined limits. Limits is an important because we are going to talk about limiting your container resources today. Okay, so that will be as part of the security aspect of containerization. Okay, so thanks for having this interesting discussion. So today I was asked one interesting question, and the question was also on the Golang. Okay, so Golang and also on the image side of Docker. So if you guys recollect our earlier interaction, so we were talking about an app called as Wordsmith, if I recollect it correctly. And 1 second, I'm waiting for the prompt to come back. Okay. So I'm going to connect to my machine now, and let's see where we were. So that day, what we did is we created some 3 images out of the code base, whichever we had. So the code base was Wordsmith. So what we did is we went inside Wordsmith, and there we had 3 components called as DB, Web, and Word. So the web was in the Golang. So we went inside web, and here there was a binary called dispatcher.go and a Docker file. Okay, so what we did is we went inside the Docker file, and we created something like this, like we chose Alpine, and then we did some, like we built the Golang binary, and then we tried to run it cmp command. So this was pretty much it. But whenever you will get a DevOps interview or a DevOps opportunity, so DevOps is like many parts of the DevOps cycle are pretty much static. You write it once, and it's highly unlikely, if it is not stable, then only it will get rewritten. Okay. So when I'm saying rewritten, as in, let's say you created a Jenkins pipeline, right? You will have a checkout stage, you will have a build stage, then you will have UT validation, then you have TDD, then you'll have code quality, and then finally, once all these things are done, then you will push your changes to your image repository or one artifactory or somewhere where you can save your artifacts, like whatever the artifacts got created. And then once that push stage is done, depending upon your system or your pipeline, either you can have straightforward deployment or you can have blue-green deployment. So these steps are pretty much constant. Okay, so once you do it once, you need not have to go and do it over and over again, right? So wherever DevOps people get job is mostly as part of DevOps enabler, right? So you go to a company or a team where they will ask you to enable them into or move their current stack into DevOps world. So what exactly happens in that scenario is DevOps team mostly ends up in handling like 70 or 80 reports, like 3-4 members of DevOps team, they'll be handling like 80, 90, 100, depending upon the project or something like that. Because they'll have scripts, they'll just put those scripts and move forward. So our job here is to Dockerize certain new repos, whatever we had, and plug them into one of the steps in the DevOps build pipeline. Okay, so let me know if you guys are not agreeing what I just now said, or if there is any deviation here. Okay, so whenever I'm talking about Docker images here, so there are two things. First is that we have Dockerized an app which we had literally no idea. Still, we have no idea that whether it works or whether it does not. But what we did is we Dockerized it. We Dockerized this app based on the descriptions, whatever we got. Okay, so if you see this image, okay, so Dockerizing a new project, yeah, that's one stage which we have had passed. But whenever we see this image, right, and then see the size of this image, so there will be some questions on it. Okay, you created the image, that's well and good, but the size of image is 679 MB. Do you think it is the correct size? So you might say, yes, it is correct size. And then they'll say, okay, tell me what is the size of this dispatcher.go. So it is something 1 some MB. That is fine. And what you will do is you might have to go and check the history of this image. Okay. So in order to identify whether your image is too big in size. Okay, so here the task is to cut down this image size. Okay, then the question would be why we are so worried about cutting down the image size. So the question here would be, whenever a developer is trying to push or pull, or let's say your images are getting pushed or pulled from the build pipeline, they'll take more time. Okay, so the more time means it will take more time to get deployed to the environment. And if your build pipeline, let's say, is running for 10 times or 20 times a day, and it's taking 3-4 minutes just to push the images to the Artifactory or your Docker Hub or whichever private repository you would be using, it's hell lot of a time. Okay, so we need to investigate on the Docker size, Docker image size, where that 679 MB is coming up. Okay, so that's one part of the discussion. And if you feel like, okay, fine, no, 679 MB is well and good. So what we can do is we can do Docker login, and here it took my login automatically as I have already logged in. So what we can do is we can do Docker push, and I'll take this image, which is web, and I'll try to push it. Okay, so we had two questions here. One is from where this 679 MB, like this much big image size is coming up. And in order to see that, whether this is big or not, what we are doing is we are just directly pushing it to our Docker image repository. Okay, so it is trying to push to something like web, and web is not a parent repository, means web is not something which I am hosting. So it will give me like, hey, you don't have request to it. So if you want to push a particular image to Docker Hub, so it needs to be in a particular format. Okay, so when I say it needs to be in a particular format, means you will have certain login ID. Okay, so which will be your repository address, and then the image name which you want to push, and also it can be followed with a particular tag. So instead of pushing web, what I will do is I will try to push now Gaurav. So it is pushing now. So you can see that the image is close to 680 MB, and it is taking this much time on AWS network. So think about it, how much time it is going to take from my local network. So this is certainly not a scalable solution. Okay, so what we are going to do now is we are going to check how we can reduce the size. That is going to be the activity for us today. Okay, so we were able to see that our image is pushed. So let's quickly go back to Docker Hub and check if our image is seriously there or not. So I don't have my image here as of now. So I'm going to refresh it. And I have this image here. So what you can do if you are in front of the system, you can quickly go and do something like this, get image pull if you want to pull it, and then this name, and then /web. So you'll also be able to have this image name in your system. So this is one part of it. Let's go back to our activity again, and let's ponder over it. What exactly we can do, what are the things we can try to reduce the image size. So far here with me or not? Like, are you guys agreeing that there is something fishy going on underneath that needs to be handled? Okay, so I'll take it as a yes. So whenever you see a Docker file, so here if you see that we are using Alpine, and then we added Go, and then we copied everything to inside the container, and then what we did is we ran the Go build, or let's say if you are running something as Java, so you can run Java C, and then you got some output, and you are just running it, nothing else. Okay, so it's pretty much the basic Docker file here. Okay, so there is something called as multi-stage Docker file. Okay, so we'll be talking about multi-stage Docker file now. So in multi-stage Docker file, what we do is we take a step, like let's say a base image, okay, and then we perform some action. Here in this case, we are copying our binary, like the Golang code, inside the container. We are running or compiling our Golang code, and then once this step is compiled, right, what will happen? We will get a output of this step. Okay, so let's say if you have apt-get installed, right? So once you do install, so you can go and use the dependency further. So something similar here is going to happen. It will in turn go and give the output of it. So why to have everything here, whatever we did here, why can't we just directly use the output and then move forward with the image creation, or rather in the final output, why can't we just use that? So instead of bottling everything, whatever we did in the first, just take the output of it and then push it inside the next layer and then move forward. Okay, so this is one concept of like, okay, so you are performing some work A, okay, and you got output of it as X. So performing a work, setting up the work and everything, you need not have to worry about it, right? So you can directly take X and run it. So take X and run it. So this is something similar to what I'm trying to say here. So we'll just see how exactly this works and how much size reduction you'll be able to see. So before that, whenever you use multi-stage Docker file, right? So how it works is you will have a stage 0, or in this case, we are following stage 0 notation, or you can have something else like first. Okay, so if you have named it as first, so what you will do is you will come here and call it as first. Okay, so but this is pretty much preferred way. Anyways, you can follow anything. Okay, so how exactly it's working is you copied everything here, you started a new stage like from Ubuntu, and then in that you are saying, hey, copy everything, go to stage 0 and copy it from this folder. Whatever is there here, copy it to the current directory inside the Ubuntu image. Okay, and then what is doing, he's also copying the static folder, and then we are just running whatever was copied from the dispatches here. Okay, so we'll see how much size we are able to save. Okay, so we'll copy this. Looks like my session is gone. One second, I'm trying to do a select here. And I want to Okay. Control D is not the right command. Control K is saying, I will just copy this one and paste it here. Let's K. Okay. So here, if we go back and see our Docker file, if we have the changes or not. So we have the changes of, hey, hi Smith, thanks for joining.
Thank you, sir.
We have recorded this session. If you have any question, you can reach out to me in person and we can go over it. Okay?
Okay. Okay, sir.
Yeah, sure. Sure, thanks. So I'm naming this one as so Smith, just to quick circle back, what I'm going to show today is you have certain images which we created in our last session, like where DB words, and they are of this much big sizes. So the exercise what we are doing today is how I can reduce this images size. Okay.
Okay.
So we are using multi here. Multi as a tag for the new web image as we are following a multi-stage Docker file. Okay. So this time we had web and the tag was multi and the image size is 81 MB. Okay, 81 MB. And we started with web, the latest one, which was 769. So if I do Docker images web, the image name, so we'll see only the web images. So here you can easily see, okay, what is happening. So can we go a bit more lower? Can we reduce it? So that will be the next question. So in order to do that, let's use one command which helps us what exactly went underneath. Okay. So what we are doing is we are using Docker history command, and we are using it on the latest one. The latest image is of 780 MB. Okay. So here you can see what exactly is happening. So this is starting with the 722 MB. So let's say it is taking some Ubuntu or some operating system, and then there we are running apt-get update, and then we are installing the Golang runtime environment, which itself was 794 MB, 574 MB, which was like heavy chunk. Okay, but the code which we were trying to run, right, it was just 7 MB. So we say that Docker is a lightweight container and all that thing, but we created an image of 680 meg, which is not acceptable, right? So that's where we started. We thought, okay, there is some fancy word called as multi-stage. So we just implemented a multi-stage Docker file. Okay. So after that, the output was 81.4 MB. So let's just run our container, whether this container is running or not, first of all. Okay, so we did not see any error. And we can see our container is running properly, so it should be well and good. If there is any issue, we'll not be seeing it running. So that's one part of it. Okay, let's go back a bit and review our Docker file. Okay, so Smith, just for you. So whenever we will have so how exactly multi-stage Docker file work is? So you will do a heavy lifting in one stage. You will take the output of that stage, which we are taking from here, and just use the output, and then you try to run your changes. Okay, so it's like you do some work, you get the output, you use the output to further go and do some other work. Okay, so the infrastructure, whatever you did to perform some work in the stage A, you will be just throwing it off. Okay.
Okay.
So that's concept behind the multi-stage Docker file. So if we remember what we discussed earlier, there is something called as Alpine. Okay, Alpine image. What it's like one of the lightest distribution of Debian operating system, right? So, and that too official. So when we talk about Alpine, let me just show you exact difference between Alpine and Ubuntu. So I am exiting from here. I am going to pull Alpine image. Okay, so I'm going to do Docker images. And here you can see this is the Alpine image, and its size is 5.57 MB. And then we have an Ubuntu image, which is close to 73.9 MB. And then we have our web, which is 81.4 MB. So there might be a question like, okay, can we do something like, okay, instead of Ubuntu, can we use Alpine? So we can try that. Okay. So we are going to further reduce our Docker file size, or at least we will try whether we'll be able to reduce or not. So whenever you see that, okay, this is Ubuntu, I will go and change it to Alpine, and I'm going to do Control S and I'll exit. Now I'm going to build Docker file, and this time I'm going to tag it as web Alpine, and I'll pass the context, which is the current directory, and we'll see. Okay, so image is built. What we'll do is we'll again search the Docker images. Okay, so we have the Alpine, and this time it got further reduced to 13.1 MB. Okay, this is pretty much promising, but let's just see whether our container is also running or not. Okay, so let me just try to run it.
To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Okay, accepted. Exec user process cause no such file or directory. Okay, so I was confident that it will not run, and I'll tell you why it will not run and how to make it work. Okay, so let's go back, and though the image size is less, but it's not built correctly because our container is not running. Okay, And what we will do now is we'll go back and check what we did in our Docker file. Okay. So here, if you see that we are using Alpine and it's the Debian distribution, and we are using Golang, which is on Ubuntu. Okay. So what happens is when you build dispatcher.go, or think of it in simple words is this is Mac and let's say this is Windows, just for the sake of discussion. And when you build or compile a file on Mac, it will get compiled with certain dependencies from the operating system, okay, which will be dynamically linked when you will run it. Okay, so what is dynamically linked? So these are operating system concepts, but let me just quickly show you exactly what it is. We are going a bit deeper. It's not necessary in the day-to-day job, but it's good to know what could be causing this error. Okay, so first what we will do, we will fix this error, and then we will go back and check what was causing it. Okay, so let's go back and do some Google search here, like Golang image. Okay, so we will get Golang. This is the official Golang image. You can verify it with the official image tag. And what I will do is I'll search for something as Alpine. So we have Alpine tag here and plenty of numbers. Okay, so we have Alpine and some version. Okay, so these are version specific. We don't have Alpine tag just directly at the root level. So what we will do, as currently it is running on Golang 1.15, so we'll just use that. Okay, so we'll go to nano Docker file, and this is our Golang base image. So we will use 1.15 hyphen Alpine. Okay, so I'm saving it, I'm exiting from it, and then I'm going to build the Docker file again, and I'm going to call it as Golang. Okay, this is Alpine, but Alpine Golang. Okay, fairly quick. And I'm going to check the images now. So we have Alpine Golang, and still it is 13.1 meg. What we are going to do now is we'll see if we are able to run it or not. Okay, so we'll use web Alpine Golang. Okay, so our server is started now. Stopping it and clearing it. Okay, so I'll just scroll back and let's see what exactly we did and from where we have had started and where we have reached. So images, web. So if you see web, we started with 680 meg. We used the multi-stage Docker file and we moved to 81 meg. There in the multi-stage, we had a second layer as Ubuntu. And then what we said, like, okay, fine. We know that we have something called as Alpine, and which is stripped down version, Debian version. So what we'll do, we'll just quickly go back and change it to Alpine. And then what we thought is, okay, so change it to Alpine, and then we saw our container was not running because we had dependency mismatch, or rather the stage 1 mismatch to stage 2. So you took the work which you did in stage 1, but that work or that file was compiled to your stage 1 operating system environment. Okay, that is where you had issues. So let me go back and show you exactly what I'm talking. And before that, let's say we have this image now and we want to push it to the Docker file, Docker hub. So pushing an image which is of 680 and then pushing an image of which is 13 meg, barely in size. So definitely, first of all, you'll save time in downloading, you will save time in uploading, and at the end of the day, you will save a lot of the time. Any questions here before I move into dynamically linked and the other things which I wanted to talk about? Okay, so I'm going to show you something here. What I'm going to do is I'm going to run a container from our base image, which is 680 meg, and I believe you guys would be familiar with this command. What I'm doing, I'm running a container in interactive mode, and the image is web, and command I'm running inside the container is bash. Okay, so I did an ls here. I'm inside the container, and here, if you see, I have dispatcher. Okay, so what I am going to do is there is a utility called as file. The only purpose of file is to tell the type of the file which we want to investigate, like what exactly it is and whether it is static or dynamic and all those things. Okay, so it's like apt-get install. It's like you have an MP3 file and MP4 file. So you can tell, okay, this is a sound file with the extension, and then you can see, oh, this is MP3, it's a video file. But what if you go and change .mp4 to MP3? So if you show it to a new person, he'll say, hey, this MP3 file, it's a sound file or a song file. But what file does is it will not just only touch the just check the extension, but rather the content of the file and then tell you what it is. So it's just the utility which I wanted to show you to for something bigger. So I use this dispatcher, and so here, let me just zoom it a bit. If you see here with like, it is saying like, okay, this file is using something as dynamically linked. Its format is ELF. So Linux linked format, and what is happening is it is using certain libraries here. Okay, interpreter is this, and this is dynamically linked. So in this whole discussion, what we should focus on is like, this is dynamically linked, means though the Go binaries are supposed to be platform independent, but they are not platform independent inherently. Okay, when I say inherently means you might need to pass certain flags when you are building the Go binary, which will make them platform independent. Okay, so what is stopping here? Because it is dynamically linked, means certain runtime requirements it is picking up from the operating system. And when you change the operating system or the CPU infrastructure below it, so what will happen? Your runtime will change, and the moment runtime will change, you will lose the magic of Docker. Okay, because it is like build the image at one place and run anywhere. Okay, so this is one part of it, and there is one more command, LDD, if I'm not wrong, or LLD. Get okay, LDD. Okay, and I'm using dispatcher here. And so what LDD tells you is it will tell you what are all the files from the system your current dispatcher is dynamically linked to or is required, or these files are required for dispatchers to run. Okay, so these are the file on which your dispatcher is dependent on. You can run this on, let's say you use cat. Okay, so it will tell you, okay, it depends on these operating system low level libraries to run. Okay, so oh, pardon me. I need to go inside the bin and then show you that. Hopefully it will work now. Yeah. So here we had that cat file and it is dependent on these binaries. So we have one low level Docker session, which will talk about the namespaces, the mounting, the network, and all those things. So there we are going to check all these low level settings. But here I wanted to show you this just for the sake of completion on what we are trying to do and the error which we face today. Any questions here so far? Am I audible?
Yes, you're audible.
Okay, so from where we started and what we have done so far. So I'll ask you guys to go through the other files and just play around it and see if you can lower the size there. Always remember Alpine, and then also remember the multi-stage thing what we have had there. Okay, so do go through it and try it. It will be an interesting journey for sure. And let me know if you face any issues.
So, Gaurav,
Okay, so yeah.
Where did it save there was a lot of reduction in file size, right? First, you are building the binary, You have
Mm-hmm.
it is a multi-stage one. So
Mm-hmm.
when you are saying from Ubuntu the second time, from Golang you
Mm-hmm.
said first time, second time you are saying from Ubuntu, and then you are copying the binary which was generated
Yeah.
earlier from Golang, right?
Correct. Correct.
And we are generating the image finally,
Correct.
right?
Mm-hmm.
I'm struggling to understand where was the saving of size actually. What got deducted?
Okay. Uh, okay. It's an interesting question. I was thinking of going there next, but
So, but if you want
let's.
to take it next time, that's fine with me.
No. 1 second. 1 second. So this is very interesting question, and um, um, let me circle back. I guess we already know the answer, but just let's circle back. So whenever you build a Docker file, right, you will see some text like um, step 1, okay, then something like a step 2. I'm talking on the console, okay. So there you will have some hash coming up, okay. And beside that step, you will have certain commands. Okay, if you're running copy, you will have copy command written. If you have run, you will have run command written. Okay, so following here, still here.
Yes, sir.
Okay, okay. So whenever you talk about any command on the Docker file, right, it will in turn go and create a layer. Okay, so we have discussed about this concept, layering. So whenever you create a layer, you will have a SHA hash associated with it. Okay. So whenever you have a hash associated with it, let's say that hash is XXX. Okay. So what exactly happens under the hood when you create a Docker image is whenever you start the executing of your Docker image from, a container will get instantiated. Okay, step 1, create a container of Golang. How you will create the container of Golang? First, you will pull the images from for the Golang. Remember, every time what we do is we whenever you try to build the Docker image, first it will go and fetch this from, no matter what. Okay, it will not look at the other steps. Okay, so first it will go query the Docker hub, get the Golang. The second thing is, okay, Golang, they downloaded it, means Docker engine downloaded it, and then what it will do is under the hood, the hash which you are seeing here, right, that will be a container hash. Okay, or it just comes, does its part, and spits out the layer, like it writes something on the writable layer and moves forward. Okay, or rather gets killed. Okay, so here first a download will happen for the Golang, then a container will get instantiated. Again, we will not see that. Okay, for us it will not be happening, but under the hood a container will get instantiated. A copy operation will happen from our build context inside the container, which will be taken care by the daemon. Then again, the next step, what will happen? So this is step 1. Step 2, a copy happen, and the step 3. Okay, so if you have a doubt here, then the next question would be, hey, I copied somewhere. Where is the where I'm going to run the build? Okay, so that's where what is happening. You created a container here, let's say parent container. You copied something inside the parent container. That will be another writable layer. Again, you perform some operation with the run command. So what will happen? Another writable layer on top of this writable layer. So that this layer will become static now. Okay, till here everything will become static. So you cannot change anything. Okay. You cannot go back in Docker and change anything. So okay, so you ran the dispatcher.go, you got some output. Okay, you got output inside the as a dispatcher folder. Okay, so let's say if I have to write it here, so you got output as uh, okay. After that, till here everything becomes static. Okay, you cannot change anything, but you have an image or a container running under the hood. Okay, then what you did, hey, I'm going to instantiate another Ubuntu container. Okay, so this is already there, and I'm running another Ubuntu container. Now, what Coffee is saying here in layman terms, we are passing 0 here, right, from the build context. Let's try to decipher it in a bit different way. So instead of 0, can we say something like, I already had a container from step 1. Okay, so container from step 1 will have, I'm sorry, this is step 1, not step 1, because step 1 will be step 1, step 2, step 3, right? So just pardon me, stage 1. Okay, so stage 1, you are going inside that container to this particular spot and then copying whatever is there inside the current Ubuntu container. Okay, then once this is done, then you are doing some other things here, and then you are running as normal. So getting the multi-stage Docker file might give you some problems. So what I'll do now is, let's go back and check it from a different perspective. Okay, so it's a very good question, but I'll make sure you understand this. So far you are able to follow me, right? That there is something called as underneath some container is getting created, which in turn is getting handled by the daemon, which we are not having visibility of. Okay, but we will, what we will do, we will try to get visibility of that. Okay, yeah, it's a good question. Thanks for asking. Okay. Anyways, I found one interesting bug on the AWS portal. Yes, I will show you one. So by default, whenever you create a VM on AWS, so initially in the old portal, it used to be like Ubuntu at the rate EC2 and then the ITOps or DNS name. But what these people did in the new portal is they are defaulting it to root. So I'll show you the problem which we face. I'm just going to minimize it. Yes. So I am inside .NET. Yeah. So usually you'll just come and enter it. Here you will get the error like root is not allowed. So this has been there for some time now. Been seeing it for a week. Okay, so we check Docker images. I am going to increase this size now, and Docker images, and I'm going to do web just to filter the web images, and we had Alpine and all those things, right? So for the sake of discussion, let's go inside the wordsmith, and I'll delete this web image, web multi image, and then prove the point that there is something else underneath a dummy or a ghost container which comes into the picture and does its job and leaves. Okay, so how to delete image is RMI remove image, and we are going to remove 3582. So I'm going to remove 3582, and it will say that you cannot remove it. So anyone can guess it from the error that you would be having some container which is running on top of it. So which is this container using this image. So what I'm going to do is I'm going to remove kill the container which is F9CE, and killed, and I'm going to remove the container now CE, and now I'm going to remove the image that is 3582. So you can see that it is also removing certain other layers here, right? These are the layers which I've been talking earlier, but let's see that again in action because it happened pretty fast. So I am inside Wordsmith, okay, and I'm going to go inside web, and here I'm going to see the Docker file again, and let's go inside the Docker file and see whether we have the multi-stage or not. Yeah, we have the multi-stage, and let's close it and Docker build -t as tag for web. We are doing revisit and passing the context. Okay. So here it is saying using from the cache, we got this, we got this, we got this. Okay. So let's check. There was a question whether how this will get copied. Okay. So the best thing for me would be Docker run -it. I use this hash, and what I'm going to do is this first. Okay, yes, it will not work. I'm going to use sh now. Okay, so you saw something interesting. Though you are building an image, right? Each step's output will be an image. Okay, so when you have the image, you can create a container out of it, right? Remember, an image can be instantiated as container. So I used this step and created a container out of it. Okay, so what I'm doing now is called as debugging step. Okay, so here I'm doing ls, and here you can see that you have dispatcher. Okay, you have dispatcher, and your current working directory is go. So what you did is from 0, okay, from 0, you took this go from inside the go, and then you are copying it inside this context. So are we able to go back and understand what is happening here now?
Yes, certainly.
Yes. Okay, perfect. So this is an interesting step, and that is how we debug it in real life. Okay, so this is the like in-depth what Docker file is, how to debug it, how to multi-stage, and reduce the size and everything around it. So with this, we are closing the Docker images. You guys can go ahead and try different things around it, but this is it. Any questions? So this is what I did today in the interview. Okay. So the question was revolving around how to reduce the Docker size, Docker file size. Okay. And that's how I reduced it to this much. Maybe I was just lucky because I know this or something around it. But yeah, so this is the real life questions. The things whatever I have had shown, I did that in the 20-25 minute exercise, and that was in a screen share. So like in the okay, so this is what like we can talk about hundreds of things in Docker, but there are something very basic which mostly we tend to miss when we try something big. Okay, so these are the things which I was asked. They were recruiting for the people for their team. I suppose that is going to work on the Golang. So the idea was revolving around Golang only. So this is one thing. Let's go back and check our agenda and try to understand. Okay, so we checked the repository. We tried to push things to repository. We checked the tagging as well because I tried to push an image with the web and it was not taking in. Then we tagged it to my own repository handle and then the image name and then the tag, and it got pushed and all these things. There are certain other commands which you can check. So one is Docker pull. The other one is Docker push. So push we already use, pull we also use. So then there is one command called as Docker search for something. So there is something which is Elastic search, which is something which I'm checking now. So here, whenever you check, like whenever you search, pardon me. Yeah. So when you do a Docker search and something, right? So this is making a request to the Docker hub and then giving you a list of the Elasticsearch images. Okay. So there is certain things called as automated OK and official. Okay. And then the stars. So whenever something is official, definitely it will have stars, more stars. And automated is like, there will be repositories like ours, which will not have any security check from the Docker end and the build check from the Docker end, but there will be other non-official but certain important repositories which will get scanned and which will take the Docker Hub registry services. So they'll have automated means. So the build, the security are validated around those images. So you will have this as automated OK. But the image, this is official, so it does not want any of the Docker related scrutiny. So not having automated, at least for Elasticsearch, which I can see. So likewise, you can go and search anything, whichever you want, and you can perform it. So then there is another concept around Docker registries, particularly. So how to tag an image in order to push it to a particular registry. So it has a particular nomenclature, like how you should make it tagged. So it follows this structure. So you will have a registry host, then you will have the username, and then you will have the name of the image, and then you will have the tag. Okay, so in order to show that to you, let's go back to the Docker images which I had. So here you can see that I have this Gaurav Vajpayee 9211. That is my username, and the image name is this, and the tag is latest. So what I have to do, let's say if I have to push this smallest image to the Docker Hub, I will not be able to without tagging it, or rather re-tagging it. So what I have to do is I have to use the Docker tag web, that is the source, and I want to tag it to my repository handle, and I want to tag it as web Alpine. Okay, I tagged it. So let's again check the images, or let's remove the clutter and only check the web. Okay, so I need to search for okay, do something like this. Okay, that is web. Okay, leave it anyways. That's not that much important. So this is the image. Okay, I tagged the wrong image. I just gave web, but web is this one, which is the latest and of 680 size. Whenever I'm tagging it, I need to give the correct tag as well. So this time I'm not only giving the image name, I'm also giving the Alpine Golang, and this time I'm going to tag it to this and Docker images, and I have this web Alpine. And now what I can do is I can do Docker push my repository handle and then the image name which I'm trying to push.
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.